I don't get the intuition of using mean value theorem to prove inequalities. Okay, let's take a look. Here we are going to show that square root of 1 plus x is less than 1 plus 1 over 2 times x. And this right here is for x is greater than 0. And we are going to be using the mean value theorem, so MVT. And let's go ahead and just do a quick review. For the mean value theorem, it's just that if you have a differentiable function, continuous on the interval and all that, but I'm just going to give you guys a picture, all right? So let's say we have a nice function like this. Let's say this is y is equal to f of x. First, we are going to consider an interval. Let's say we want to go from a to b like this. So here is f of a, here is f of b. Then you're going to just draw the secant line, like this. All right, so if you look at this line, it has a slope of what? It's just y2 minus y1 over x2 minus x1, right? So the slope is just f of b, which is the y value here, minus f of a, which is the y value there, over x2 minus x1, so b minus a. The mean value theorem says that on this interval, there must be a c value, at least one of them, at least one, somewhere in between of a and b, so that if you draw the tangent line there on the curve, what I'd like to show you is just that use a pen or pencil or marker. If you just kind of place your marker on the secant line and just move up or down. If you move down here, you can find a curve and you can see that it's about right here. And if you draw the tangent line here, you will see this tangent line and that secant line will be parallel. And the slope right here is precisely the derivative, which is denoted by f prime, and we call this value here c, like this. So this is the mean value theorem. All right, to use the mean value theorem, the first thing is, of course, we need to come with the function. Here, let's pick the function square root of 1 plus x. You might be wondering why. I think just try to go with the more complicated function, which is the square root in this case. And on the right hand side, you will see that it somehow turned out to be quite nice because it's just linear, right? So I'm just going to say, consider our function. Consider our function to be square root of 1 plus x. And then here, remember, we just care about x is greater than 0. Of course, that will be in the domain of this right here as well. So consider this, and we want to care about on the interval going from 0 to some x value. And now this interval makes sense because we are saying x is greater than 0. So imagine x is 17, then we're putting in here, then we're talking about the interval from 0 to 17, including the endpoints. And then to continue with the mean value theorem, we should mention that since our function f, there are two things I should really mention. One is continuous, CONT for continuous, on the interval including the endpoints. Which is, if you look at the square root function, right, just keep that in mind. And you should also mention about its differentiability. It's deable, meaning you can take the derivative on the interval. When you mention the differentiability, you do not have to mention the endpoint. It's just 0 to x, so parentheses. So that's just like the standard thing that you should mention. Plus, it is nice behaved on this interval, so depending if you need to do more work on that or not. All right, so from here, we can go ahead and say, since this happens, so, let me just put on so, by the mean value theorem, there exists a c value, and the c value is going to be on this interval without the endpoints. So I will write here c on the interval like this, from 0 to x. This is just a notation saying that you can also write it as c is in between of x, it's in between of 0 and x. Right? Meaning somewhere here, but we don't want the c to be on the endpoints, right? Not that. So there's a c value on this interval here so that this happens. And let me just write it down right here. On the left hand side, we have the usual slope formula. on the right hand side, we have the derivative of the function as c. Alright, now we can just go ahead and plug in the things that we need. Well, a and b, the interval here is x to 0 to x, so this is a and that's b. And our function, let's just also denote that if you take the derivative of square root is 1 over 2, and then the inside, right, square root of the inside. And use the chain rule, but you multiply the derivative of the inside is just 1, so it doesn't matter. So our b is dx, so this is f of x, and then minus f of 0 over x minus 0, and that should be equal to the derivative at c, which is 1 over 2 square root of 1 plus c. Now, what's f of x? That, right? So I'm just going to put that down right here. This is the square root of 1 plus x minus f of 0. If you put 0 in here, you get square root of 1. Let me just write that down like this. Over just x. And that's equal to this right here, 1 over 2 square root of 1 plus c. Now, you can see that we have an equality here, and also this c doing here. So that, what exactly do we do to continue, right? And I think this is the hard part when we do the calculus proof, and especially any proof involved in inequalities, such as when you do the epsilon delta proof, when you have to do the inequalities. That usually gives us a lot of confusions, because it's unusual. Here, what we are going to do is, we are going to ignore the c and then use some inequality. And let me explain that for you. Firstly, I'm just going to mention that since, because we know c is greater than 0, now we can say, right? Then I'm going to say that we know that if you have 1 over 2 square root of 1 plus c compared to 1 over 2 square root of 1, where I just take away the c, which side is bigger? Well, if you have square root of 1 plus c versus square root of 1 when c is greater than 0, because square root is an increasing function, when you add a c to it, we know the left hand side will be bigger. But we have the reciprocal. So when you take the reciprocal on both sides, you have to flip the inequality. So it becomes like this. Multiply the 2 on the bottom, that doesn't really matter because it's just positive 1/2. So since c is greater than 0, we're taking away this right here from the denominator. The whole thing here becomes less than this. Alright? So that's an important part that we need. Okay, I don't really have much space. So alright, so I'm going to put the work over there. So on the left hand side, we still have this square root of 1 plus x. And that's just minus 1 over x. And then now, this right here, which is equal to 1 over 2 square root of 1 plus c. But as we mentioned here, this is less than 1 over 2 square root of 1, which is just 1/2. So if you look at this inequality, I'm just going to multiply both sides by x. And actually, let me make it more clear by writing this down one more time. So we can say this is less than 1 over just 2. And then I'm going to multiply both sides by x. And note, remember x is greater than 0. So when we multiply both sides by x, this and that cancel. We just have square root of 1 plus x minus 1. And we can just maintain the inequality because we are multiplying both sides by a positive x value, 1/2 x. And then, ladies and gentlemen, let's just go ahead and add 1 to both sides. Square root of 1 plus x is less than 1 plus 1 over 2x. And there we have it. That's the inequality that we need. Put a box, shade it in, and feel good about it.